Hello everyone. I am Sharan Almeida, roll number 305 from St. Xavier's College, Fort Mumbai. And in this video, we will look at an important ore of iron, a beautiful mineral. Well, at least it is to me. I hope you find this mineral beautiful at the end of the video as well. And that is hematite. Well, hematite is known to be an abundant ore of iron in the world, having the chemical composition of Fe2O3. This one is a strong mineral. The top three properties it shows are streak, its ability to grow various shapes, forms, and its interesting magnetic property. But why is it named hematite? Why not something like grapes or silver bubbles? Where does this name even come from? Well, this name comes from the red lines it makes when rubbed across a streak plate. The streak is one distinguishing physical property of hematite which separates it from the other ores of iron. Say thanks to this guy, Theophrastus, who in the 300-325 BCE in Greek originally named the mineral as Hematitis rethos, meaning bloodstone or blood-like, because of its strong red color powder or streak. And in the modern form evolved by various authors, it changed to hematite. Now that we have looked at streak, let's look at the other physical properties of hematite. Color, the second one being the streak, third one being the luster, fourth one being the diaphanity, then we have the hardness, the tenacity, fracture, the cleavage, and the specific gravity. Now, as I said, hematite shows very interesting magnetic property. The magnetism in hematite depends upon the shape and the size of the mineral. Now, if you read what is written here, the Néel temperature is a temperature above which an antiferromagnetic material becomes paramagnetic, and the Moraine transition is when the material aligns itself parallel to the C-axis. The various different forms of hematite are discussed below. Let's now go into hematite and look how hematite looks in the bond form. Hematite looks like this in the crystal lattice form. Let's now look at how hematite looks under the microscope. This is the view for the PPL, while this is for XPL. HEM is nothing but hematite. As we can see, it is black. Many of the ore minerals do not let the light pass from them. Further are the uses of hematite. From the various uses, some of them are given here. They are the main ore of iron, making pigments, ballast. A ballast is something which is used as a central balance used in ships or bridges because of high density of hematite. Radiation protection for stopping X-rays. Polishing. Hematite is used to make polishing compounds known as red roug and jeweler's roug. Red roug is a powder used to polish brass and other soft metals. It can also be used for tumble polishing brass shell casings. Jeweler's roug is a paste used on soft cloth to polish gold and other silver jewelry. It is also used as gemstones to make jewelry, beads, and tumblestones. The different ores of hematite found in India are as follows. Some of the interesting facts of hematites that I like are the BIF. That means hematite was long ago on Earth in the BHQ formations. Then we have the iron rows. They are rounded clusters of the tabular crystals of hematite. Then we have the rainbow hematite, which is nothing but the iridescence property shown by hematite by phosphate minerals deposited on one part or one side of it. Interestingly, hematite has also been found on Mars. NASA's Mars exploration rover Opportunity in 2004 discovered that the soil near its landing had millions of tiny spheres, and the researcher nicknamed them as blueberries. Upon analysis, they came up with that as iron oxide, mostly in the form of hematite. The iron content of the Martian rocks and the soil is also red in color. That means that hematite contributes to the red planet name of Mars. Here are the resources that I've used to make the content. Thank you so much for watching.